In this video, we're going to find the resultant of three forces acting on a particle. The question reads, three forces of magnitude 8 newtons, 50 newtons and 10 newtons act on a particle Q. Find the magnitude and direction of the resultant of the three forces, giving the answer to three significant figures. Here's a diagram showing the directions of the forces. First, I'm going to resolve all the forces in the y direction, taken upwards as positive. For the 8 Newton force, because it's 40 degrees from the y-axis, its y component is 8 cos 40, since we're finding the adjacent. For the 50 Newton force, because it's 55 degrees from the x-axis, its y component is 15 sine 55, since we're finding the opposite. And the 10 Newton force acts straight down, so it gives us negative 10. Adding these up, we get 8 cos 40 plus 15 sine 55 minus 10, and this gives us 8.415. Now I'm going to resolve in the x direction, taking rightwards as positive. The 15 Newton force points to the right, so its x component is positive 15 cos 55. The 8 Newton force points to the left, so its x component is negative 8 sine 40. The 10 Newton force is purely vertical, so it's not got any x component. This gives us 15 cos 55 minus 8 sine 40, which is 3.461. Now I have two perpendicular components. The horizontal component is 3.461 and the vertical component is 8.415. These two form the shorter sides of a right angled triangle, and the resultant force R is the hypotenuse. Using Pythagoras, R equals the square root of 3.461 squared plus 8.415 squared, which is approximately 9.10 newtons. The final step is to find the direction, so we're going to find the angle theta. We're going to use the inverse tan since we know the opposite and adjacent forces. So the inverse tan of 8.415 over 3.461 gives us theta approximately equal to 67.6 degrees. In summary, the resultant force has a magnitude of 9.10 newtons, acting at an angle of 67.6 degrees above the positive x-axis.